Okay, fully new topic. Not algebra anymore. You are doing basically tradie maths. The first topic that we're doing is finding the surface area of solids with planar faces. What do I mean by planar faces? The faces are flat. No curves. No curvy shapes here. So there is a formula for the surface area of an object that has planar faces. It's the sum of all the faces. What do I mean by sum? Addition. I'm adding them all together. Now notice that under here, this formula assumes that you know the area of different face shapes. I'm going to remind you about the ones that you need from now until year 11. So firstly, can you get this formula? Surface area of an object with planar faces is the sum of the area of all faces. And then we're going to go through individually each of the area formula below. Planar faces. Planar faces. If you wanted to replace that word, it could be flat faces. Anything that just has flat sides. Yeah? So if you haven't seen any of the first three of these formulae for 2D shapes, you need to tell me who had you before, because I need to talk to them. Are you aware of the area of a rectangle? It's the length times by the width? I'd very well hope so. What is the area of a triangle? It's the base times by the height of the triangle, and you divide it by 2. Why is that the case? Because all triangles are half of a rectangle. Any triangle you can convert to a rectangle and find that it's half of that. One key is that the height is always at right angles to the base. Because some of your questions might be tricky. You might have a triangle that looks like this. Okay, maybe we do know the base, but if you're told that is 5, I don't actually have enough information to find the area of this purple triangle because I don't know how tall it is. Right? If I was told that this gap here was 3, then I'd have enough information to work out the height of the triangle, because now I know the hypotenuse of that triangle on the right hand side. I know what one of the sides is. I could work out the height of the triangle. Okay? So see how we have to be pedantic about the base and the height have to be at right angles to each other. I hope that the area of a circle is not new to you. The area of a circle is pi times by the radius squared. What is the squared applying to in the formula? Does it apply to the pi or does it apply to just r? Just r. Please don't do what my year 11 general maths kids were doing. They were finding pi times by r and then squaring the answer. Why is that wrong? Because you're squaring all of it. You square the radius and then you times the answer to that by pi. So get like a quick version of all these diagrams. Parallelogram. This one, I don't know. I'm not going to get angry if you haven't seen that before. Parallelogram. The area of that is the area of the base times by the height at 90 degrees. Why does that work? Because this is just a rectangle. And you're going, what have you been speaking, Mr. Twizen? That's not a rectangle. Well, if I took off this triangle on the left-hand side and I put it over here, do I then have a rectangle? So that's why that works. Can you get that down, please? I'll get the trapezium into the view. What is the trapezium? A trapezium, you find the average of A plus, you find the average length of A and B. So you go A plus B divided by 2, and then you times it by the height of the trapezium. Just for interest's sake, because you're ignites, and like I often get questions about that. Why does that work? Because if I found the average between A and B, that's going to be a line that is exactly halfway between that corner and that corner. And you're going to get a line that's exactly halfway between that corner and that corner. And what shape have I just drawn? That is a rectangle. All right. And what's that rectangle? How does that rectangle relate to the trapezium? Well, can you see a little triangle hanging off here in the bottom corner? Where would that fit? That would fit here. Where would this little triangle hanging off to the side be? That would fit here. So once again, the trapezium is a version of a rectangle, explaining where the formula comes from, okay? You don't need to know where the formula comes from. You just need to be able to use it. So that's that. Does anyone need more time to get those, I think it was 5 shapes down? No? Let's have a look at the kind of question you'll actually face. Find the surface area of the 3D object below. Does that shape have planar faces? Are there any curves there? No? What formula am I going to have to use? What are the external sides of this? There's 3 different kinds of shapes here. Any thoughts? Yep. Triangles, 1. Someone else? Yep. And one more. The square at the bottom. Okay? Now, some of you are going to jump to conclusions and tell me the area of this triangle is going to be base, which is 6, times by the height, which is 4, divided by 2. Can you tell me why I'm wrong? Do I know the height of this triangle? Is this triangle that's on this 3D pyramid, is it standing up directly straight and tall? Or is it angled slightly? So you need to use our friend, our little Greek friend, I don't even know what his name, I don't even know what nationality he was. We need to use Pythagoras to work out the height of this triangle. Because if I did little dots here, the height of the triangle is actually this, from the top, down the middle, to the bottom edge. Okay? And so that would be the hypotenuse of a right angled triangle that went directly up into the air and formed that. Any guesses or any thoughts? How long would this side be? Based on the information I have on the diagram, and assuming everything is straight, up and down, how long would that be?
Would it be 3 centimeters?
Yeah. This would be 3, because that is half of the distance all the way across. How tall or how long is this vertical line? 4, because you're given that. Do we have what we need to work out the height of the triangle? So you use Pythagoras. Let's call this C. C squared is equal to 3 squared plus 4 squared. C squared is equal to 9 plus 16. C squared is equal to 25. C is therefore 5 centimeters. So now could I find the area of one of those triangles? Yes or no? Area A of triangle equals base. What's the base of one of those triangles? 6, not 8. 6. 6 is across it. So base 6 times height, which is 5, divided by 2. So what's that going to be? 6 times 5? 30 divided by 2. 15 square centimeters. Once again, I'm going to be pedantic. Would some of you be tempted to say 15 centimeters squared? You can admit, that's fine. Everyone does it. But that's kind of wrong. Because 15 centimeters squared is 15 centimeters times by 15 centimeters, which would be like, is that 215 or something? I don't know off the top of my head. You have to be pedantic about the units. We have 15 square centimeters in area. There's a slight difference, okay? So what would I have to do to find the area of the pyramid at the top now? Because I only have one triangle. Any thoughts? What would the area of the triangles around the pyramid? Yeah, but how many of them are there? 4. So area of, let's draw a little pyramid here, is going to be 4 times 15 is going to be 60 square centimeters. If that shape would exist in real life, would there be an area to consider underneath that pyramid? Is that sort of exposed? No, that doesn't exist. I'm going to ignore that. What shapes am I going to consider now if I'm going from the top down? Rectangles. How many rectangles? Area of rectangle is equal to length times width. So it's going to be 8 times by 6. What's that? Is that 48? How many rectangles are there? How many? 4. So 48 square centimeters. So area of the rectangular prism is going to be 4 times 48. What's that going to be? I suck at the mental arithmetic. So use the calculator. 4 times 48. 192 square centimeters. There is one more shape that I need to add onto here. What was it? Someone said it. It's like a rectangle where the sides are all the same. So the area of the square at the bottom indicate that it's a square with the dashes. 6 by 6 is 36 square centimeters. Why do you reckon I've underlined those 3 numbers? Because that's what I'm going to add together at the end to find. What do we say at the top? Sum of all the area of all the faces. So total SA is going to be 60 plus 192 plus 36. 60 plus 192 plus 36. 288 square centimeters. That's what you're doing, okay? I'll stop the video.